One. Hi, folks. So today myself Shrikant here, and we have a guest, Parth Lokhande. He was my colleague and he was my intern in my earlier companies, and it is great to have Parth on board for this podcast session.
Yep. Thanks, Srikanth. Thanks. I'm glad to be here.
Yeah. So I'm just sharing my screen and just to have one quick overview. Parth's profile. So Parth is currently working as a DevOps engineer too, and he has done engineering from this college from Pune, and he was an intern in this company ConnectWise, and he was with me for 2 months. And after that, he joined full time to ConnectWise, and he is currently a cloud engineer too. And to his credentials within 3 years, I think he has achieved a lot. So yeah. So over to you, Parth. Can you please introduce yourself shortly?
Yeah. I mean, achieved a lot sounds like a very overstatement, but yeah, I've got so I started, like you said, as an intern in ConnectWise under Shrikant's guidance, and we worked for a while in the QA department. After that, I've been mostly working 2.5 years as a DevOps engineer. All of my domain has been DevOps, all of the tools that you find in the market, most of them like Kubernetes, ECS, AWS, also CI/CD tools like GitLab CI, which is one of my very strong suits. Others can include the generic Linux skills and everything that the DevOps engineer needs. So yeah, it has been a huge learning curve, very steep, since transitioning from a fresher to DevOps is the sort of a difficult thing. But yeah, I've been enjoying the journey.
All right. So let's get
Mhm.
started. So after introduction, I typically ask the same question to every guest in my podcast. So if somebody
Mhm.
wants to join uh, into DevOps, right, or who want to start
Mhm.
career after graduation into DevOps, of course there are
Mhm.
courses are there in market, YouTube videos are there. But what uh, tips you want to give to them? Let's say you want to prepare a CV or some interview tips quickly.
Okay. So the first thing I would suggest that there are a lot of courses out there, of course, but the first thing that I think any engineer and a DevOps engineer very strongly needs is Linux. Because without Linux, you'd be crippled most of the time because everything you start, let's say AWS, you spin up an EC2 machine, you need to know Linux to configure it. You need to write some CI/CD, you need to know Linux. So I would suggest that you first start with Linux. For the interview preparation and everything, the best thing to do would be doing some personal projects because just watching some videos on Udemy and just going through all of that will not help you. You can just watch a video, okay, he spun up an EC2 machine and everything. But what errors do you get while spinning it up? What errors do you get while configuring the network? You can only run using projects. So that would be your first step or the your stepping stone into the job, into the field. Yeah, I would suggest that for sure.
Okay. So you
Mm.
mentioned to do hands-on, try hands-on on some of the cloud platform. Let's say AWS is very popular, and there may be others
Yeah.
like Google and Microsoft Azure. So AWS being very popular, even anybody I can, I mean, I was also part of it. So I can spin up an EC2 instance from UI itself, or any, let's say I want to do a Lambda function and those things. So what is it that basically will help if you do using program this scripting?
Okay. So mostly into the industry, we use something called as in infrastructure as a code technology. So there are major two. One for AWS is CloudFormation, and the second is the Terraform, which is generic for all clouds. So spinning up any infrastructure like PEC2 or Lambda using scripts or more prominently as IAC will help you because you can create a template, right? Like every time you don't have to go to the UI and configure everything that you need to configure. All you can do is write some code in a file and then reuse that file to spin up multiple infrastructure instances. For example, if I just need to spin up an EC2 with specific configuration, I'll write it as Terraform and then spin up in different accounts, even cross-platform and cross clouds. Yeah, so you can do that. That's a huge benefit.
Okay, so in that sense, yeah. So scripting in that sense. if there is a template available that can be given to anybody, or you can also do it, or we can configure in some Jenkins job or somewhere, which on demand we can do that activity. That is what you want to say, right?
Yes, yes. With a single click, you can configure all of your infra setup in matter of seconds every time.
Okay, so infrastructure as a code is a new concept. I mean, I kind of knew it,
Mhm.
but yes, just came to know. Okay. um,
Mhm.
yeah, upskilling. So let's say somebody has some background and they have made their hands dirty by spinning up some instances and understanding uh, little bit failures, let's say ECT, EC2, S3 bucket, and some basic things, let's say
Mhm.
ECS and those things, right? Now upskilling, so
Mhm.
basic things somebody knows, let's say that person has worked for 6 months, 1 year, he knows some here and there log analysis. What about upskilling? What two things, three things you would suggest to upskill?
Okay. To name a few specific skills, I think for DevOps, as I said, the stepping stone would be Linux. After that, for upscaling, you can learn the newer technologies, right? Like most of the time in the market, wherever I see people use Jenkins for the CI/CDs, and for container orchestration, there's always Kubernetes. So for upscaling, the path would be something like from Linux. Then you can start with the cloud. Maybe you can learn AWS or GCP. Once you know that, you can learn containerization, you can learn Docker, and then after Docker, you can learn Kubernetes. And after all of this is done, you can dive yourself into more advanced concept for to upscale yourself. For example, you can learn about GitOps, you can learn about MLOps, how you can manage ML models as containers and everything like that. So this could be a good roadmap for someone who's entering the field. Yeah.
Okay. Now, right, so upskilling, interview questions, basic. Okay, now let's deep dive into your core experience and that kind of stuff.
hmm
So basic thing is what challenges you faced, top two or three challenges you faced till today. You want to highlight whichever you faced and how did you overcome.
Okay. I would like to re-emphasize and re-emphasize on this point because challenge as a fresher or someone who's new to the industry, the biggest challenge you face when you enter it is that you are not aware about 90% of the technologies. Because even in college or as a developer, you're taught the generic skills, right? Okay, learn Java, learn Python, or let's say learn web development. But DevOps is a field that is a very niche concept and it is required everywhere. So there is a lot of new technologies where you're which you're not aware about, and all of them, like I said, Linux is needed. So it was a very hard path for me because I even didn't know Linux when I joined. Then I had to learn all of these technologies in a span of just 3 or 4 months, and it can be very taxing to you. That is one of the major challenges that you face. And the work that you do in DevOps is a lot, a bit different or a lot different from the work that you do from in college or as a developer or as a QA. Because here a lot of things depend on your configuration and the stakes are very high because if you do something that you write some wrong IAC code, it could cost your company, and that could be a huge disaster, or you make a security vulnerability somewhere. So being careful was another challenge, and the learning curve was a big challenge for me, for sure. Yeah.
Okay, so being cautious is the main thing I would learn from you, that being
Yeah.
cautious, if you make small change in the script or somewhere, that
hmm
first thing is as a cost, second thing is what you said is
Yeah.
security related things, and that
Yeah.
might cost multiple things for the company, for the organization. Okay, so good point. Now, so typically what happens in our normal software development or even software testing, somebody new joins, normally, or let's say a fresher, we nobody takes that much risk on that person. He from very reputed college and all, so they may be given some maintenance work, some basic um, script handling, or just correct this script in the existing script. So in software development, what we do is we give them a very typical bug fixing work. So bug fixing work,
hmm
what will happen is that person will understand the entire code, or see that code one time, two time, 10 times, and then, so in terms of DevOps, uh, let's say at your level, what assignment you will give to a entry level person? Top two or three assignments.
Okay, the top two or three assignments. Yeah, I think I'll take this from you as well, and generally what we do here as well. So what you can do is make the interns or the new freshers work on some internal projects first. You don't give them directly applications that are client facing. Maybe there's a tool that you need internally, like we and Srikanth worked on a project for log monitoring, right? When I was an intern. So such kind of projects might help maybe make them write a pipeline to deploy an internal tool that helps people manage Jenkins pipelines, right? So these kind of projects would be the first step. Another is, like I said, debugging. We can assign the sometimes the pipelines fails, right? And DevOps engineers get a lot of tickets because the pipeline failed or there is an issue on some non-prod EC2 machine. So what we would do is that we would give them the work related to non-prod that is directly not affecting the production environments. Maybe give them some bug fixes in the pipelines. So develop their Linux knowledge first and their CI/CD knowledge first. We wouldn't handle them give them anything to handle that is related to secrets, let's say, which is which should be very secure. So yeah, such kind of non-prod environments and pipeline fixes would be my first step.
Okay, all right.
Mm.
Um, So, being from non-DevOps or those kind of background, so I'm
Mm-hmm.
from quality engineering background. So we have
Mm-hmm.
for projects like we have Scrum ceremony, stand up, daily stand up. So we discuss about
Mm-hmm.
typically functional aspects of a particular project.
Mm-hmm.
Okay, let's say there's a user story, you know. There is a UI, so your user will come and he will enter some values and then click on submit. So developer will develop the form, QV will test it, and those kind of thing. But let's say a DevOps team, right, or a cloud ops team. What is their day-to-day Scrum? Like, what do they do? Of course, there will not a user story, right? So, typically what is being discussed?
Okay. So this is a topic that is very different across companies. The practices that the DevOps team uses or the CloudOps team uses. This you'll find that there's a lot of variety that's in the market. The work that what I have worked with is Scrum. So even we use Jira. And yeah, it is not a typical discussion as you would have in, let's say, a development Scrum team or a QA Scrum team. So DevOps lies a bridge between the ops world, where people work in Kanban sort of a model, because they have to be on shifts and watch the systems if they're up, like sort of an SRE thing. So that would be a system where someone instantly raises something that is a problem, and then someone has to pick that up and instantly fix it. It's like the on-demand and resolve model, right? But in DevOps, since it is sort of a bridge, you can work in scrums because we just don't work on issues that are on the ops side, right? We work on issues that are on the dev side as well. For example, there is some code in development that is causing the monitoring system to fail. For example, you implemented some new code and your monitoring system doesn't support it. So we also take up that ticket. We discuss in a Scrum how to make it better. We have the same activities as sprint planning and everything. Okay, how can we make the system better? And even we take up some development work. We improve that code and then deploy to the system. So Scrum could be a really nice way of working as a DevOps engineer for sure.
Okay, so yeah,
Hmm.
little bit inside about uh, some production failure or some log monitoring related thing, or maybe some
Mhm.
internal script development for the betterment, cost saving, or high speed, or some pipeline setup. Okay, right.
Hmm.
Um, any typical bottleneck you think, in general, like what are the bottlenecks? Let's say you take up some design work, okay, you're writing some script. So you will need
Hmm.
some requirement, like why I'm writing the script, what is the expectation? So typically, can you give one example?
Okay, bottlenecks. By bottlenecks, you mean like what barriers I face while writing the script, or
Yes. Yeah.
okay, okay. So, as far as the industry is concerned, when you work on a personal projects, you know full of the project end to end, right? But when you're working something on an industry level, on a junior engineer level, most importantly, is that you don't know the complete system, right? And whenever you write a script or you develop a system, you develop from your own perspective. So, a huge bottleneck could be that not knowing what is around the script they are writing. For example, I am, let's say, writing a script to clean up an old S3 bucket to save some cost. But if I don't know the S3 bucket that I'm cleaning could have some important data that some other team knows. So that could be a huge problem because if I go ahead and run that script and clean it up, then there could be a huge blunder between teams. So a huge bottleneck is that context. Every DevOps engineer should have the most context he can have to keep the system better. If he doesn't have context on the development side or something he doesn't know from the QE side, I delete some QE job that I thought we didn't need. So that is a huge bottleneck that industries face as DevOps engineers.
Okay. So in
Mm.
general, you are saying awareness about the existing system and being cautious, like if you do something, is that going to affect other teams? And if they really need it, we don't clean it or whatever. So those kind of thing. I think similar, we can talk about the database upgrades. I have faced this in many earlier
Mhm.
projects. Suddenly there is a cloud of mail or DevOps mail that they want to upgrade the Postgres to newer version, okay, because let's say AWS want to stop the support of the existing version, they want everybody to go to next version, but then the development is
Mhm.
not ready, the developers are not ready because they have to do a lot of things, right? So then this kind of thing, uh, again it's a cautious thing, we have to be careful. Sometimes even I've seen, we said, development said, okay, go ahead and update the Postgres database in the cloud, or some AWS database, right? What is
Mhm.
that name, Redis or something.
Yeah, yeah. Redis is cache, yeah.
No, no, there's a specific name from AWS database, Redash or something. I forgot. Okay, so
Oh, Aurora?
Aurora, So,
Okay. Mhm.
so it so happened that sometime it went smooth. The upgrade happened properly. Even they did it in production, and sometimes
Mhm.
even they upgrade on the lower environment, let's say Q environment or SIT environment. There
Mhm.
only the DevOps guy will say, no, no, he faced some issues. He will revert back, right? So those kind of
Mhm.
issues, I think, will be challenging. Uh, hmm, okay. Um, right. Going
Correct, yeah.
to the next point, CI/CD. Okay, CI/CD scale. So this is the, you know, a very widely used, and this is a very general aspect, or the one of the key skills for a DevOps engineer. CI/CD pipeline setup, CI/CD pipeline management, right? So typically,
Mhm.
like, can you walk me through, like, let's say I'm from functional background, right? So I have some code. I will say that, okay, it's a Python
Mhm.
based code, it's a microservice. This is the code
Mhm.
in this particular repository. There is a branch. Okay, now we want it to be deployed and tested on the QNM, right?
Mhm.
So walk us through, what is now our job is finished. Now your job starts. So what is it that you
Mhm.
need from our side to deploy this on QA final?
Okay. So the first thing that we need from any development side or any QA side is that whatever application is, it should be independent of its environment. For example, if it is reading something from the OS level, and we deploy it to a different OS, that could be a problem. If it is directly calling AWS code inside it, for example, there is a parameter stored in AWS and you're directly calling that parameter inside that code, that could be a problem. So what we need, or any DevOps engineer needs from an application, is that it should run completely isolated. It should read all of the values that it has. Every application has variables, right? Let's say XYZ. It should read those from the containers environment variable, because if we can create a container that can run in your local, that can run on GCP, that can run on anywhere Kubernetes, it becomes a very easy job for us. That is the first requirement that we need. Yeah.
Okay. So
Hmm.
after that, what after that?
Yeah. After that, yeah. So after that is done, there comes Docker, which is the biggest tool that you use to isolate your environment, right? So once we have a really nice Docker image that can run anywhere, and after that comes the job of pushing the Docker image into a registry, right? So all of this will work after that, that you take the Docker image and push it to a registry. After that, your containerization environment, maybe Kubernetes or your EC2 or your ECS, to pull that Docker image. All of this code, which is generally done through Bash code, Linux, is done through the CI/CD pipeline, right? So the first job for us would be to test it. Once the container is created, we first test it. If the container is exposing any secrets, if it has any code smells, we use tools like SonarQube and to check the quality of the code. If the code is good enough to deploy to your non-prod or to your prod, that would be the testing phase. After that comes your non-prod phase. For example, your testing is done and your pipeline has been up. So you develop an intent environment, you deploy it, check it there if whatever code you have written is breaking or not breaking. You see if there are some issues in your application, and then you can deploy it to QE environment. So again, some people would ask, why are you testing two times? Like there is also a test and there is also QE. So the tests that are run after the build are just the tests that you check in general, right? The performance testing and everything that QE runs comes into this environment. We keep a different environment for the QE team to run their tests and for the int environment for developers to develop, so that they have two different environments, right? And once you deploy to QE, then the QE team can go ahead and run all the kinds of tests they need. Even if it breaks, it is okay. It doesn't break anything for the other team, development or any other team. Yeah. So that is the general flow.
All right. Yeah.
Mhm.
So I think that is the the point what we are discussing. So
Mhm.
CI/CD at scale, right? So basic
Yeah.
pipeline stages. Check out the code from some
Mhm.
source code management. Let's say GitHub, GitLab, Bitbucket, some tool. Then
Yeah.
of course code review will be development team will be doing the functional team. Then the EC2
Yes.
or ECS spin up and then code deployment, right?
Yeah.
So let's say this is sorted out. Okay, one
Mhm.
question I had, I just want to ask. So
Yeah.
when you say our service microservice should be independent,
Mhm.
but let's say very simple, right? So in a in a project where there are multiple microservices, right? Typically they would need
Mhm.
authentication from a common service, right? So that
Correct.
part I think
Correct.
may not be independent. That part has to be there on some dependent uh, microservice or dependent uh, Docker. So what is your take on it?
Mhm. Okay. So, for that, if you have a microservice architecture, it is still, I would still suggest that even the application that provides the key or provides the authentication mechanism, even that be independent of the cloud. So, if you have such a dependency, what you can do is that whatever authentication mechanism you have, you can run it in a non-prod environment, and whatever you test on local, right? That local container should contact through the internet to that service on non-prod. And this service should only be accessible by your office network or your VPN connection with it. I know that you cannot always make 100% dependency free, whatever your application has, because that is the general case in microservices architecture, right? So that could be one solution. Whichever authentication microservice you have, you can expose it to the internet for local testing, not the complete internet, but just your office network and everything, so that developers may work on it. That would be one solution. Or you can make your application as such that whenever it runs on local, right, you can provide some mock token, and it recognizes the mock token and still carries out all of the functionalities it needs to test on local. That's all. Because on local, we don't need a full scale application to contact each and every service, right? We just need to test core functionality so that it is running fine. So that could be another solution.
Okay, exactly. That's what I was thinking.
Mhm.
To have an internal
Yeah.
network, let's say VPC, virtual private cloud,
Hmm.
or even
Yeah.
VPN, just to restrict outside requests, but inside company or inside company network, it is fully available. Okay, and yes,
Yeah. Yeah.
the mocking or stubbing, that is also a good solution, right?
Yeah.
Okay.
Hmm.
Moving on. So EC2 versus ECS, right? So it's a big
Hmm.
debate. I know it's a big debate. Uh,
Yeah.
can you give typical places where you will prefer EC2 than ECS or vice versa?
Oh, typical places where I would prefer EC2. That would be for me, the use cases where just the machine is needed are very less, because that would be a case where you want to configure your own sort of, let's say, a database, right? If you have something like a stateful application, you mostly avoid running it in containers because it needs a volume mount up and everything. For example, let's say you want to run a MySQL database. Instead of putting a container every time, mounting it, and if the container goes down and handling it, I think it would be a better solution if you create an AMI. AMI is just an Amazon machine image, which is a snapshot of an EC2 instance. So you can create your database image out of that and then deploy it. So stateful applications are something that one might consider deploying on EC2. Otherwise, if you have something like a microservice, which can go down and come up anytime you want, which can run on some other machine, which can for which we can need to increase more power. In such cases, it's always a good idea to go with ECS or THS or whatever technology you have. Yeah,
Okay, okay. So,
yeah.
right.
Mm-hmm.
Okay, now coming to the health check, right? So I know
Mm-hmm.
there are different aspects of health check for a particular microservice. So
Mm-hmm.
normally what happens is there is a endpoint health. It's a
Mm-hmm.
get call, and then some logging system will repetitively call it, or in the code itself we can repetitively call it. Let's say every 2 second or configurable number of seconds. And if the
Mm-hmm.
success code and the response is fine, then there is
Mm-hmm.
health is okay. It is assumed, right? So
Yeah.
this is very typical, I would say. But what other things you would suggest to have a health check for microservice?
Okay. To have a health check for microservice, I would suggest that you have a better monitoring system. So health check cannot just be, hitting a URL and checking if everything is going right. Health check can also see if that your application, if it is running as a container, if it is instantly consuming too much memory. So that is also a problem, right? It's not just that you hit some URL and you're getting 200, but what if those containers have 10 containers have become 100 containers and the health is getting okay? So on the infra part, if you let's say consider usage, just hitting a health API URL is not enough. To have a proper health check mechanism, you need to have a better monitoring system. It could be Dynatrace, it could be Datadog or any of your paid solutions. Or there is some other a new tool called as Signos, which is an open source tool you can run into your system as well. So yeah, um, just using the health checks is not a good solution. You can also use the health checks provided by Route 53 service in AWS, where it checks that all of your regions are fine and it can also fade over to another region. So yeah, Route 53 is also a good solution for health checks.
Okay. So apart from
Mm.
just the endpoint calling, you are saying memory
Mhm.
utilization monitoring and maybe CPU
Yeah.
spike monitoring, and of course the paid tools Route 53. These are
Yes.
other systems or items available which can be utilized for health monitoring. Mm. Okay, so
Correct. Yeah.
especially the finance related thing, right? So if some payment related
Mhm.
microservice goes down, it's a big
Mhm.
havoc, right?
Yes.
Okay, right. Now quickly, in the interest of time, um,
Mhm.
the second point. So multiple concurrent project handling. Uh,
Hmm.
do you have any experience? Like how do you think about it quickly?
Oh, yes, yes. I'll quickly explain it. So, so what happens in here in the industry is that always you have multiple projects. I do have, in fact, a lot of my experience contains managing multiple projects. So I would suggest whatever code you have for CI/CD, right? You create a standard architecture for it. If you have a standard architecture, it would be easier for your teams to manage as well. So you create your basic stages, let's say build, deploy, non-prod, and you fix this flow across your organization. And once you have fixed this flow, you can write all of your CI/CD configuration files and store them in a central place. So that is one of the biggest steps to take when you're managing multiple projects. Take all of your generic boilerplate code and store it in one place, and just keep changing the variables in your child projects. So that is the biggest solution for this problem, actually, managing multiple projects.
Okay, so going step by
Mhm.
step, boilerplate code and reusing the existing stuff. That is what
Mhm.
you are saying. Mm. Okay,
Correct. Yeah.
right. So in the interest of time, Parth, so thank you for your time.
Yeah.
Right.
Yes.
So I'm sure there is a lot of takeaway for the community from this podcast. Definitely,
Oh,
we will meet one more time for the next session. And
yes. Yes. For sure.
yeah, thanks, Parth. So yeah, stay tuned, everyone. Please like, subscribe to the channel. Thank you.
Yes. Thank you for having me here, Shrikant. Thank you, everyone.